So, I'd like to just review some things here before we go on, and that is going through the discovery process. This is the first time I've run this class remote, and normally I'm right there to help with discovery issues, and you will be sick of discovery by the end of the week. Because you will be discovering again. The only thing you're not going to be installing is the admin node that's already been installed. So I'm not sure who had problems yesterday actually seeing my desktop now, but I've switched to my desktop.
Megan is seeing kind of an aqua blue screen. Okay, now I'm getting your desktop. It's coming in.
So you should be able to see a web browser. Oops.
Yes.
So I had to click on the state to be able to actually get a button here. Now, everything about discovery is the BMC, when it boots or initializes, is going to put out a DHCP request. The admin node is going to see that on VLAN head, put it into the database, assign it a host name and an IP address. If the MAC that's coming in with the DHCP request is already in the database, Discover will just simply say ignored. Now, we did have one problem yesterday in Connie's cluster. Everything is tied together through the CMC. The chassis management controller has an Ethernet switch in it. If in this case it appeared that the Ethernet switch was hung or not responding properly, such that the BMCs coming in from like the service node or the lead node were not getting to the admin node. They weren't actually on VLAN head. I'm going to explain that a little bit later, but just keep in mind everything is tied through a switch. If the switch has a problem, you're not going to see BMC requests or DHCP requests come in from the BMC. Now, that particular node 3 was actually running a beta tempo 2.1. That might have been related to why the CMC was not responding properly. Also in our labs, if we're switching from Platform Manager Scali to Tempo or back, sometimes the IP addresses and stuff that are being used are different. And then you have to go into the CMC and basically reboot it. Worst case scenario is you go to the IRU and drop the breakers, then bring them back up. The CMC is on all the time as long as power is supplied to the chassis. So it's a vampire device. So when these nodes are up and running, the BMCs do have a release time interval, something like 6 minutes last I looked. So if you have nodes that have not been discovered that are powered up, they could end up putting in a DHCP request and grabbing the one instead of the node that you really wanted to be discovered. So the intent is to unplug or power off through the back of the chassis, in our case a power strip, turn off anything that has not been discovered. Otherwise, it could send out this 6-minute DHCP release request and grab the IP address and the discovery from you. So if you look at my web page, I'm going to just take George, and the login and the leader are presently powered off. And I'm just going to say that they're not discovered right now. Okay? So normally, if you had 100 racks, you'd be going down the racks, they'd all be unplugged, power cord would be pulled in the back, and then as the discover script says, this is the rack that I'm discovering, you would then go find that rack and plug it in. Plug in the rack lead controller. Now, there's also an option on Discover to use a MAC file. That is being used by manufacturing. But there's a script to actually generate the MAC file for you, and that is not integrated and supported yet. So you do have the ability of avoiding this power cycling for discovery by using that MAC file. If you type in discover like --help or -h, there'll be a -mac file, and it'll explain the syntax, and I'll come back to that. So everyone sees, I'm just going to take George. I'm going to bring up Putty now. And I only needed the BMC, like George-BMC, to be able to image the admin node. Once that first boot is done and your networks are configured, I would always go to the SSH port. It's faster. If you're coming in through the serial port, there is a difference there in speed and stuff. So I really only need that serial port if I'm going to power cycle, boot, that sort of thing on the admin node. So is everybody able to see my Putty window now? I'm on George-admin.
Yes.
So I'm just going to do a cadmin -- version. And I see that this is running Tempo 1.9. Now you all were installed with Tempo 1.10, and then there's 2.0 that just came out, but there are a couple of day one patches that are required. And Tempo 1.2 is down the road, next release. So in my mind, Tempo 1.10 is the most stable right now. There are some patches and problems with Tempo 2.0. I'm also going to do a cat on RHEL asterisk, and I can see that this is running /10 SP2, which is the last, Tempo 1.9 is the last release to support /10 SP2. So Tempo 1.10, only /10 SP3 or /11 or Red Hat 5.4 were being supported. We okay?
I think so, yes.
There was a slide in the overview on the releases that match up and stuff. But that's not going to bother me right now. It doesn't matter. I'm going to try to do the discovery process. Also, I'm going to do a console -X to see what's discovered. So right now, it does seem to have a service and a lead node that are known, but I'm going to rediscover them. And it does not show any compute nodes visible there. And some problems that look like they're connecting through R1 lead. All these connections are through SSH. And I think it was Connie's machine. I actually had to remove on the lead node the root.ssh/known host file to actually be able to get SSH to work through it. So RSA keys jumped or changed or something. Got to be a little careful if it was a prior class's root that you're up on, and then the RSA keys don't necessarily match. So I was suspecting that that might have been some of the things that I saw with Connie's situation. And again, you need to power off these nodes. I'm going to do a cpower -- system. and just see what it finds for me. So there we are getting a timeout coming in from IPMI tool. Now CPower is actually using SSH to get to the lead node. So it's not liking that, getting to the R1 lead. Well, in this case, though, we're not SSHing, we're IPMI tool to it. So again, I want problems. I'm okay with this right now. See what it finds about the service node. We are going to start getting into debugging and in lab today and tomorrow, and most of tomorrow will be lab really. I have very little to talk about tomorrow. Tomorrow is getting your system ready for customers, end users. So I'm seeing things are not healthy on this George cluster. And I'm not even going to be able to reboot if I can't get IPMI tool and power status to R1 lead or service 0. So let me just go into configure cluster, see what I've got there. So it is noticed that there is a database already built, so I don't have to do an initial setup menu. But what I'm going to do here is go down and reset the database. This is not necessary for you to do. I'm just thinking aloud and working on this system, since I am going to rediscover the cluster and currently the nodes are not responding to me anyway. I'm just going to give this a shot here. And it will delete the database, getting rid of all the discovered nodes. It means I have to rediscover again. So it's going into the database now and just cleaning things up. Now it should also give me the opportunity to either recreate my images or use the existing images. Since I don't want to wait 45 minutes, I'm just going to try to use the existing images. So database reset. Now you should proceed to the initial setup. Oh, it didn't give me the option. Okay. So I'm just going to have to do this. Normally it gave me the option of keeping the images. So that just cost me 45 minutes. But we can use that time for lecture. Right now it's just running yum to generate checksum information and cache on there. You do have to worry about these caches in var cache yum. They can get rather large. And yum has a clean all command to clean up the stuff in the cache so that the var cache yum directories don't get big.
Question.
Yeah.
Could you have perhaps saved the images if you went in and maybe had access to copy them somewhere else first and then do the initialized database?
No, because they're still not in the database.
Okay.
But they're traditional. I haven't been using 1.9. 1.10, you get a prompt to say whether you want to save the images or not.
Okay.
Now I did see some other kind of error message. Oh, here we go. So here it's create default images, return an error. It means the default images already exist. I'm going to use the existing images. So this is what I was looking for. I was thinking it was in the reset. So it cleaned it out of the database, but now we're going to use the existing images and basically add them back into the database. Let's just see how this goes. Now you can always tar up those images, but then they're not necessarily known to the database. Okay, so that looked like that worked. Just going to check house DNS, and do we have for, I've got to check. It was like a 192.48.176.12. And that's something that you'd be getting from your IT person. Connie, are you still online?
Yeah, I lost my phone there, but I'm back.
Okay, I just saw the email now. I'm just pulling up my lab instructions, but I'm pretty sure that IP address is correct. Not 248.176. Yep. And then OK. Now setting DNS forwarding is going to put this IP address in the ITSI named.conf, wherever named and DNS is running. And then it's restarting named there. Did see a little bit of a red error flash. Named not running. I'm going to ignore that. I think I've got a bug in that area, but we're going to take a look. Sometimes you do have to restart named when you're making changes. I'm going to go back, and let me just quit out of here now. I'm going to do a console-x, and there's nothing there now, as expected. Okay? So now I'm going to do a discover. Before I do this, discover. There is a syntax example with the discover help. A lot of times the documentation is in the command no man page. So here's an example of what I was saying with a MAC file. Once you know your MACs, all MACs need to be discovered. So it's the name of the host, the BMC's MAC, the host. And there is a script floating around manufacturing that once they've discovered by plugging the power in, they can generate this file automatically. Everyone okay with that? That would avoid the power cycling. But I don't know my MACs necessarily yet, and I just want to start with the documented vanilla way, which I'm going to discover --rack1. And I can put --service 0 at the same time. Now, I don't like to put too many at once because the output message from the discover gets too messy, and you might miss power on requests because it scrolled past the screen. Now again, the rack and the service, anything that's not discovered is powered off at this point. And by powered off, I mean unplugged in the back so the Vampire BMC is turned off. So now I'm going to hit enter. And if I'd already discovered it, it would have prompted me to say it's already discovered. Do you want to remove or delete the prior entry in the database? Since I reset the database, it's not there anymore. So here's the message that you're looking for, and saying, okay, we're waiting for rack 1. It says, please turn on the power. That means plug it in on the back. But it says, do not turn the system on. That means do not push the button in the front that's going to activate the CPU logic.
Yes,
so the motherboard is going to be powered up by Discover via IPMI tool. All we're supposed to do is plug in the back. Then the BMC will boot and do a DHCP request, and we'll see it coming in. Also in the back of the workbook, I do have the MAC addresses, unless a node has failed and something might be shuffled around. So I'm just checking here on page A78. I'm going to be looking for a MAC address coming in that's going to be a B82B as the last 4 octets. B82B. So it's waiting for me to turn it on. So now I'm going to go to my web browser, find the lead node. That's what it said on rack 1. On immediate, and apply power to the power cord. And now we have to wait a little bit. So this PC has been plugged in the back, and the BMC, the Vampire device, now has power to it, and it's going to be coming up, and we should see its MAC address coming in. In the meantime, if I have other nodes that were already discovered, their MACs may come in, but it'll say already in the database, ignored. Or if it was something that wasn't discovered but I did not turn off, it's possible that that could grab the discover, and then I've imaged the wrong node. So there, B82B, and I'm just double checking, that is the MAC of what I was expecting. Got associated with this R1 lead BMC, and notice right now it now has said we have restarted the console concentrator. So from that point on now, discover is asynchronous from what's happening on the node being imaged. Do a console-X, and we see R1 lead is there. By the way, as long as the con server is running, barlog consoles has output. Okay, anything that went to the console output. I'm going to do a console R1 lead, and I'm basically looking at what looks like a prom initialization. Again, some of you may have had trouble with escape characters. Let me see, I haven't had any problems here, but Control E, C, dot broke me out. Control E, C, question mark gives me help. Keep in mind over here now, it is in the process of powering up that node, and we're seeing that node boot for the first time. We're still in prom initialization.
So Dave, I can't get the Control E to work.
Control C, and then E, and then dot.
Control C.
Control C, then an E, then a dot.
Okay, so the lab is wrong.
No, it should be spelled right in the lab.
No, it's Control E followed by C dot.
What page step are you on?
Well, just look at A22. Maybe I'm not hearing you right.
A22.
Yeah, I'm seeing Control E as in elephant.
Yeah, I'm not seeing any typo there. Control E as an elephant, C for command, and then the command.
I misheard you. I thought you said Control C.
No, I meant Control E space C. Notice here now, if I can, while it's happening, another discover prompt has happened, but it can scroll off the screen. Now it's already got this one coming in and already in the database, so that one's being ignored, but it's still waiting for me to power up the service node. If I had 100 racks and said discover all 100 racks, these things can scroll off and you can miss them. So I'm going to go to the power strip and power up the login node now. I'll get back to that console thing in a second here.
That's fine.
So now there's power up there. I'm doing things in parallel here, so here I can actually see we're now syncing. So we basically have a mini root, mounted that mini root. So we have a memory resident root running on the lead node that partitioned our disk drive and now mounted it, and now it's syncing it. I'm going to do a Control E as an elephant, C dot to break out. Okay? If I go back in, hit enter, there's nothing there because it's sitting on the rsync. A Control ECP for playback will play back the last page, the last stuff that was in the log. So in bar log consoles, the playback option went in and played back out of that log. So now I can see that it's sitting on an rsync. And you can get timeouts at this point. Meanwhile, over on the other side, my service node, 64FE, let me just check it. It's always good to sanity check your Macs when they're coming in. And 64FE is in fact the service node's BMC MAC address. So we now have the service node being discovered as well. Control EC dot, got out. So console on service 0. Again, I can't, there we are. We caught it right at boot. Now if you remember, if I wanted to actually catch BIOS, I'm going to do a shift backspace. I'm hitting it, but notice there's no reaction on the console. It will not tell me that it found it. The notes will say delete if you're on the physical VGA console or using the KVM web interface to the BMC, it's the delete key. But if you're coming in through IPMyTool, it's shift backspace. So I should actually be able to see BIOS come up here in a minute. I could hit a Control C and go into LSI utility there too, but IPMyTool distorts, or some of the characters don't get through to do things. Let's see what happens here now. Oh, it looks like I did not catch my BIOS request. So meantime, over here, my discover is now done, but the nodes are not discovered yet. I'm going to go back to console. Let me just do this one, service 0. Look what it told me. Somebody else is already attached to it. If I try to hit something that says read only, so to steal that, Control ECF to force, and now I would have control on the left screen. I'm going to do a Control EC dot to break out of there. And we're now watching the service node get imaged. It's basically still booting up drivers and stuff. The other window, I'm going to go back to R1 lead and see what that's doing. So R1 lead just mounted a device. So when you connect with the console command, Control ECF to steal it, Control EC dot to get out, Control ECP to play back the last page. Okay, now I'm also noticing on this George, some of my customized scripts are in place. We're going to talk about that today. So right now it's trying to set up InfiniBand and stuff. So it's been customized a little bit. Over on the left, my service node has just done the make FS on roots and stuff. On the right, we're basically rebuilding your elalo.conf and your initRD, doing a make initRD type of thing. Now it's creating the swap files on the right. So my lead node has a swap for every 64 nodes that are in the rack. This is hotly debated because of heavy swap locking up the lead node, or if there's no swap, hitting the out-of-memory killer. Talk about that later. So on the left, I see my service node is now actually getting an rsync. So I've mounted the disk And again, it is finding labels to figure out we're going to reuse the same labels. Anything that was out there already is being overwritten in terms of the SGI boot, SGI root type of labels. Over on the right, I'm still watching it make 64 swap files. And they're both still in the imaging portion. They've not actually done their first boot yet. And now it's finished with its imaging on the right. The lead node is now going to reboot itself. And during every boot, there are some configuration scripts that run too. We'll explain that today. Any questions right now?
Not at the moment.
So one of the problems was the CMC hung. Let me do something here. I am remote, so I have the problem. Again, each of the IRUs, the CMC has a little cable that goes to an LCD display. The bottom side of that LCD display has a DB9 connector for serial port. My DMZ server has USB to serial dongles, if you want to call them, that basically plug into these serial ports underneath. If I was actually at the machine, I could use Minicom or CU, something like that, and connect into these serial ports. Since I'm remote, they're already set up for me so that I can get into the CMC and reboot it. So I'm just going to do a CU-L TTY US0. Hit enter. I have personally, each of these CMCs has their own file system, and I've written into the file system's message of the day which particular IRU I'm on. Okay, I'm going to go in as root. Password is root. And I'm now into the CMC. And we've got some other VLAN IP addresses in here as well. BusyBox is your help. This is a BusyBox OS. By the way, I now see the service node is running some custom scripts of mine that you're going to do today. One of the things I try to do with this class is to make the cluster bulletproof. In other words, if I have to re-image a node, I don't have to do anything by hand later. My custom scripts will make that thing a golden root and make it user-ready when I'm done, except for NIS. There's a problem about pushing maps around with NIS when the entire fabric and network interfaces are not all up. So I want my cluster to be able to survive power loss, re-imaging, and upgrades too. So, looks like my service node is about ready to reboot. Imaging is completed. My lead node has now finished booting, but it is not done yet. So on the left, there goes my service node on its first prom boot. And here now, notice we've got BT launch many. This is the BitTorrent daemon bringing stuff in. So we've imaged the lead node's root, but we have not imaged the NFS roots that the compute nodes are going to boot from. If I do a tail on var log messages, Right now it's actually setting up the DNS stuff too, network time protocol. I'm waiting for it to actually start to see the BitTorrent stuff. Over on the left, we still got the service node coming up for its first time. So a lot of that stuff was DNS coming in. Now we're starting to see the image, in this case /10SB2, that the BitTorrent daemon is bringing in. It's a tarball, and we're just going to watch the size grow. So the service node, the lead node is now bringing in through BitTorrent the image that's going to then be placed in varlib SGI, which will be the root for the 64 hosts that are in that rack. We okay right now?
Yeah.
Also down here, there are a variety of things you can do, but basically what I did for Connie yesterday was a power space off and then a power space on. That does not shut down the BMC, or I'm sorry, the CMC. That shuts down the logic attached to the CMC. So if I do a power off, the IB switches, the Ethernet switches, and the logic to connect to the blades for their power, control, fan, and temperature, that logic is powered off and then powered back on with the power on command. That's how I reset it remotely. If I'd been there, I might have just popped breakers. Some people don't think this is good to know, but if I did power off with no space, that would shut down the CMC itself. And remotely, I had no way of turning that back on again. Somebody would have to be physically there to pop breakers. So using power off with no space is how I actually shut down the CMC itself. But this power off is basically going to recycle the logic to the Ethernet switch. I'm suspecting it hung just because it was running a pre-release 2.1. Very, very small OS here. Not much going on in it. My service node has now booted. My lead node is still bringing in the tarball. That's going to take a while for that to finish. I'm going to just log in here as root, SGI, and I'm into George. That's my login node. That's what's going to get connected to the public network and where we're going to compile and run applications from. We okay?
Yeah.
Now, bad habit. Somebody might, from one connection, hop to another machine and then hop to another machine. I've had many people do this. Control EC dot, I break out. Okay. Half hour later, I come in and say, console, service 0, hit enter. Hey, I'm not on service 0. The best have been burned by this. Good habit to always log out. Get back to your login prompt. So in class, if somebody thinks they got the wrong host or something's messed up, exit, and now you know you're back to where you belong. So watch out for that. It's a bad habit to sit there SSH and then SSH and then SSH around. Also, any of those console connections, you know, somebody else can come in and now whatever you were in, they're in. Even though they may have a console connection, they might not have access to one of the accounts that you're using, and now they're into that account. So watch out for that sort of thing. Control EC dot breaks me out. And again, in var log consoles, these are going to be the consoles for all the lead and service nodes. And then on the lead node in its var log consoles will be all the compute nodes. So if somebody goes into a console and does RM star from slash, you'd be able to find it. Anything that's done on the serial console is logged. So in the meantime, we have to have patience over here as that tarball is brought over. But we're also going to have patience for it to actually build the bar lib SGI. I'm going to go back over here, SSH to service 0, and I am able to get in. But it does not have public network interfaces configured. It's missing a lot of things. It's not a usable node yet. So after we get InfiniBand running, we then have to get this cluster user ready. So this morning's topic after this demo is InfiniBand and then customizing. And basically most of tomorrow will be customizing lab. I don't know how much we will get together in the morning tomorrow, but there isn't really much lecture except answering questions and reviewing. Usually Wednesday is get the system ready and then send me email when you're ready to put a user on it, and then I'll log in and start telling you what problems there are, like I can't get the compilers and things like that. I'm going to exit out of service 0 here, console-x. Notice I do have 2 lead nodes that are discovered now, but I doubt they're booted because they don't have a root yet. Let me just try a console R1, I0, M0. So rack 1, IRU 0, which is the bottom IRU, and then M0 is the node in the IRU which starts in the lower left corner. And I hit it and there's nothing there. Control ECP playback, nothing there. That's because it hasn't booted yet. Control EC dot and I'm back out. I'm going to SSH to R1 lead. Again, there is a SI monitor.log file that's on the node that was being imaged. If it's a failure, if the image fails, imaging fails, and I hope you see that the next day, I want you to see some failures, that file is still in /temp. When it's successful, then it gets put into root. So I could take a look at that thing and see what happened during imaging. I see the kernel boots. And then I start to see the system imager scripts that are doing the things. Starting the network, DHCP request, getting the binary tarball. BOEL is a special kernel that's used in system imager. Is Brian's only type of kernel. rsync some scripts in, and then started actually making it, partitioning and making FS on my file systems. So, and then now here's an example. We're going to get into this later, where it's actually customizing and setting up some things in my image to customize it. There's the swaps being made, that sort of thing. So when successful, the root will have an SIMonitor.log. If it fails, it will still be in /temp. Now this imaging that was being done there is in a init.rd type of root, and then the disk is mounted and cherooted into. If there's a failure, it falls out of that cheroot. So the actual login shell that you get on a failure is not the environment that it was imaging from. So normally we boot the system, Pixie, Linux, and init.rd. The init.rd then does your make part, your mount, and your rsync, and then cheroots into it and does things. And if something fails, it falls out of that cheroot. So we're going to get into that imaging process today. Also, I'm just going to get out of here. SGI SBIN. got a lot of scripts in that area, things to migrate for changing spare nodes. Here's what I was just looking for just now that I'll talk about later. If something went wrong with my SSH keys across the cluster, this repair SSH root keys should go in and repair the RSA keys that are in the roots.ssh directory. There's one thing that's different between Oscar Temple and the Scali platform. Scali platform put everything in ITSSHD. Oscar and Temple puts it in the individual accounts in the .ssh directory, which makes it a little bit harder to maintain when they're scattered all with multiple users around the place. I'll come back to that later. So at this point, I'm thinking let's take a quick break and see what happens here. I don't want to sit here and spin too long, and I didn't want to start the next module quite yet. I've got 10 to the hour. Let's take a 10-minute break. That sound okay?
Fine. Yep.
So we see you at the hour.
Okay, Dylan.
So if anybody is online right now, I'm seeing that we're now actually generating the routes for each of the hosts.
Okay.
We'll start up in 4 minutes.
Did you just reboot your entire George system?
No, I did a C-Power -- system just to get status.
Oh, that's status, okay.
Yeah, -- system by default will give you status.
Okay.
-- halt is what I'm going to do next once the imaging is done. So you'll note that the 2 compute nodes are still off and not booted. We're still building the roots over on the right.
Yeah, 40 out of 64.
until the system is cleanly put together, you can get junk email, also junk reboot messages. So like I say, you got to have patience. If you're not actually watching this, you might think the lead node is finished, and some students will often power cycle at this point before it's actually finished building the roots. I'm going to go into var lib SGI. There's my swap files, a single root FS, so in there, root FS, we've got one image, and then everything that would be a common root for everything. And then our per host are the unique directories on a per host basis. So I'm just going to pick one node, I0, N0, and in there, ITSI /ROOT and /var are unique to each host. But they all share one common /bin/sbin type of directory.
And the SC root and var are NS mounts from R1 lead to each computer?
Yes. So we'll see once the compute nodes are up. So is everyone back? I heard Megan. Is Connie and Kevin back?
I'm back.
Kevin, you back yet? So it's just finishing up. Again, when you left, it was basically still pulling in the BitTorrent, and now it's actually building the root. And I went in on the R1 lead into var lib SGI per host, image name, node name, and right now it's building these ITSI's roots and var directories on a per host basis. This is what I mean. You got to have patience. You want to make sure that the imaging finishes. So some people will, after the reboot, after the imaging is done, think it's finished, but it actually hasn't pushed the compute node images out yet. So another thing I need to warn you about, we're going to get into CImage later. So CImage is determining what image. In this case, it was a compute /10sp2 image. But what image we're going to push by default, show our default. It right now is basically doing a push-rack. Okay. And we can list images and list what images nodes are running on. And we can also set to boot off of a different kernel, for example. Another thing is a command called cinstallman that you're going to play with today. And this is an important thing to realize. You're going to be getting into customizing today. And if the custom changes don't show up, Tempo has the tendency to use off the existing tarball that was created and not refreshing that tarball. I don't have this refresh-bt in any of the lab steps themselves yet. But if at some point you make a change and you don't see it, refresh-bt is something to consider. So we're going to get into these commands today. CImage and cinstallman. Just about wrapped up here. We're waiting for the 64 of 64. It's finished. And I'm doing a C-Power -- system. You can actually see the C-Power coming in, SSHing. Now for your information, C-Power is running IPMI tool to get this. Is the power on or off? Then is checking with SSH to see if SSHD is pinging, is responding on that particular node. If SSHD isn't there, or we're still in the process of booting, we won't see anything there. And here, now we're starting to see the power up commands for R1I0N0. And we should get the next one up here. There's R1I0N1. So they should be booting now. I'm going to do a console. R1I0N0. And it just picked up a kernel from the lead node. Here we can see where it's actually serving the kernel for a Pixie boot. Again, the compute nodes have no disk, so they're getting it all off of a Pixie install server. That's the lead node. And then they're booting off of an NFS. And there we are seeing the NFS mounts occurring. And here also we can see the NFS coming in. So I'm just watching a compute node boot now, and watching the lead node with all the bar log messages on the lead node. And it looks like my compute node is finished. I do a DF, we can see where it got mounted from. So there's root, ITSI, var, and /root. We also have temp, which is memory resident. And you're going to be customizing for this part, but this machine has already got my custom scripts in it, so that I'm actually getting a home, an SW for compilers, and a /archive mounted here as well. So I'm just going to get out of there. Again, I'm through the serial console. It's always good to leave a serial console at a login prompt. Don't leave it logged in somewhere. Control EC dot, and I'm back out to the admin node. I'm going to do a C-Power -- system this time. Again, we have 5 nodes, 1 admin, 1 lead, 2 computes, and a login service node. One of the clusters actually has 4 compute nodes in it. I'm thinking that that's George 2, but it might be George 3. Has a couple extra blades in it. So notice now again, power on, that's coming from IPMI tool, and booted saying SSHD is up and running on that system. I'm going to try a cexec host name, and now I can get the host visible as well. Now this cluster was automated. I'm going to get in that this afternoon for customizing, but the next step would be to configure InfiniBand. Before I do that though, Control EC dot, I'm going to do a C-Power -- halt. Let's see if it takes it in proper order. And halt the system. I kind of like to make, before I go on with customizing and stuff, I kind of like to make sure that I can power cycle the cluster and survive the power cycle, including the admin node. I don't want to go on and make custom changes and find out something went wrong and I can't survive a reboot. And now C-Power, when it's doing this stuff, has got like a 300-second poll There is a lab there where you do C-power with the -V to watch it actually do the polling. So it's sitting there 300 seconds waiting for each phase. Right now it's shutting down the rack lead controller and its nodes, then the service node. Anybody have any questions right now?
Not at the moment.
Again, while I'm waiting, let me just get out of here. So now I'm coming into the serial console because I want to power cycle the admin node as well to make sure that everything can come back up the way I want before I proceed. So yesterday we basically already had the admin node imaged and was at first boot, and then you did one boot, but now I'm going to boot it again. Then we used configure cluster to build our repository, which by the way in TFTP boot. And then we've got SGI, we've got distro. Let me go into distro. And in there we could have Red Hat or SLES. And in there, that's all of our RPMs. This is a yummy repository. So there's checksum information, things like that in there. Also the SGI directory. So in there we've got Foundation, ProPack, and Tempo RPMs. And this is one thing these repositories have. They have a repo data and a repo cache. And we're going to talk about a command called crepo that maintains these repositories. And they have checksum and lists of what's actually in the repository. You can't just drop an RPM in there. You actually have to make the repository aware of any additional packages. That's where we're going today. So I'm going to do a C-power -- system. So there we see R1 lead is off, not booted. And it won't be able to get to any rack blades if it's off, so it is possible you drop the lead node and the compute nodes could still be powered on and you don't know it. Service node is powered off. So I'm just going to do this last reboot here. Basically I'm saying, can I survive a reboot of the entire cluster including the admin node? So this is something Thursday I'm going to test on everybody to make sure their cluster is somewhat stable. And if I had somebody there, I'd actually drop power and see if it can survive a power loss too.
Console command would be the only way to see the console in the event of a power cycle that fails. For example, it couldn't find the root image, or for some reason you had a new kernel and it kernel panicked, and console would be the only way to retrieve that information.
Again, in varlog consoles is going to be the history behind it. You will see messages in varlog messages on power up, power down, power failures. There is a tempo heartbeat going on to make sure things are up and ready. Gangly, it can actually set off some alarms if you have a voltage or temperature problem. I'm not sure I answered your question. I got timed out here. I'm just going to go back in. It already is active, so I have to deactivate and then activate again. Now I can see it coming up with prom again. And I think, Megan, that was you with the question. I'm not sure if I got your answer.
Yes, I was just thinking of power cycles when things fail really early on, like it can't get the network information it needs to do an NFS mount from R1 lead or something. You made a typo in the digits.
Again, if it's during imaging, that SI-monitor.log. If it's after imaging, var log consoles or var log messages. That's where I'm going to find any diagnostics.
Thank you.
And again, we can always try something too. If you want somebody to drop power on a blade, we can do that. I'm going to hang nodes and stuff later in the week, panic it, do some things of that sort. So I'm just making sure that my cluster is going to survive a reboot right now. I'm waiting for the admin node to finish its boot. And I'm also watching for any sort of boot errors to make sure I know what's normal or unnormal. So after this node is up, what's the next thing I do? cpower -- boot. I may have lost my console again where I'm getting an SOL timeout. There we are. Broke me out. I've got a year-old PV on that. And went back in. If you're connected, Control-C will not break you out. If it loses connection, Control-C will break you out. So I'm going to come in. I only use the serial console for boot and shutdown, so at this point now, cpower -- system, -- boot. Or here I'll log in, do a console, service 0. And there goes service 0. With this boot, that's going to be the very first thing you see. Now, once the system's up, I would advise you to have some sort of integrity check to make sure that the cluster is intact. An MPI application you can run, something like that. Intel Cluster Ready, Intel Cluster Checker is a real good one as well. That's a licensed product, though. Everything that leaves Chippewa Falls has passed the Intel Cluster Checker. If anybody wanted to play with that and learn that, I can cover that on the side. That's usually the second week that we talk about Cluster Checker. I don't think you caught it very well when we were talking, but the boot of the admin node actually had 4 slots, and only one of them was populated. And then the rest of the cluster is going to come up under the same slot. So we can have, depending upon your disk drive, 2 or more routes or slots that you can boot up from. So you could have SLES10, SP2, SLES10, SP3, SLES11, Red Hat, but the entire cluster has to be on the same slot. And I saw a couple of annoying messages, but I'm not seeing anything fatal. What was the one that I saw here earlier? Could not set up default, that's okay, we're not there yet. Not sure I like this one though. And again, these are some custom changes. I don't know what the state of it is. I'm just going to go in, DF. I got everything local. What I did not get was this one here. Let me just see if I can ping L3-George. It is there. Mount-A, DF. It does mount. It looks like a timing problem. I'll have to look at that later. Waiting for the rack lead controller to come up. Now I'm logging in. I just created an account for myself real quickly. And the first time you log in, you're going to get your .ssh stuff all generated on the first time in. RSE keys and stuff like that. No route to host, yes. Within the cluster, the admin node is just known as admin. Oops. SSH root at admin. I'm not getting anything, so control ECP for playback. Seeing a whole lot. Oh, there it is. Still booting. Now, should I have 10,000 nodes and maybe 4 or 5 don't come up, then there is cpower -- boot that will only boot those that are not booted. So the lead node should be booted here rather quickly. By the way, in terms of a cluster, the service and lead nodes are not considered part of the cluster. And when they talk about time to boot the cluster, they're only talking about compute nodes. I'm just waiting for the compute nodes to respond now. Service came up, the lead came up. Now we're waiting for the compute. So that was a little bit of cpower and console. I'm not sure if that was enough exposure for you. Here comes the compute node booting now. Now tomorrow I'm going to be giving you some code examples, MPI codes and stuff that you can run to test the cluster once you've got it put together, user ready, libraries available, all that sort of stuff. And again, what we can do, Connie, to test your scenario is I can go to the web page and just pull the plug on the service node or the lead node and see what tempo does. It will take a few minutes for the heartbeat to set off alarms and stuff.
Okay.
And Ganglia will tell me if nodes are not there. In fact, let me do this now. So for my case, George-admin/Ganglia. And here I can see I've got 8 CPUs, I got 3 hosts up, none down, and I can see the data. We're going to get into Ganglia a little bit later, Thursday. But it will take a few minutes for host down to show up. So my compute node is now okay, control EC dot, cpower -- system. This is interesting to me, open iSCSI, which is usually where NFS or swap is being done. And the name service cache daemon had a complaint too. So cpower -- system shows the system's all up. I'm going to do a cexec df. And now I can see each of the compute nodes. And note they also have the customized. You don't have this yet. That's going to be by tomorrow, having these NFS mount points going. I'm going to SSH DAW at service 0. I'm going to do a cexec host name here. And it is prompting me for password. It doesn't know who I am. Let me get out of here for a second. So I needed to push the ITSI password. Instead of using NIS yet, I'm just pushing ITSI password and ITSI shadow. We'll get into NIS later. I'm just doing it quick and dirty. And now we're okay. So, and I can see I created an XX. So I've got this home DAW that is mounted on the compute nodes, and it's actually on a second disk on my login node. This way, if I lose my root, I can re-image my root without losing my home, or /SW is where my compilers and profiling tools will be. So the whole point here is to have a golden root, and if I lose that root, a discover will give me a root that is ready, user ready, ready to use. I'm done with the demo right now. Any questions? So I'd like to go to the workbook now.
Hey, where was that demo, Dave? I'm sorry, I was gone.
Which demo?
The one you just did.
Well, we did it live. It did get recorded. It'll be something you can pull down later.
Okay, thanks.
So I want to talk on the InfiniBand module, take a break, and then do the customize, and then you're off to lab. Okay? So, where your system is, you're not quite ready to say what tempo is supported. You still have to configure InfiniBand by hand. So 4-2, identify key InfiniBand features, describe the fabric, identify some of the hardware issues, but basically there's going to be an OpenSM daemon that has to be running to configure the route tables for the InfiniBand switches. And also you'll be running some basic InfiniBand diagnostics in lab. So, InfiniBand is a low latency, high bandwidth, low CPU usage fabric. Just another form of an interconnect. Normal Gig-E Ethernet may have bandwidth but does not have latency. Anything going through the TCP stack, anything going through normal Ethernet is going to have latency, say in the 90 microsecond range. When we go to DMA access and bypass the kernel stack, which is what InfiniBand and NumaLink types of things do, we can drop our latency down to 10 microseconds for InfiniBand and between 1 or 2 seconds for NumaLink. NumaLink will still outperform InfiniBand in terms of latency, even NumaLink 3 or 4. Memory to memory is going to be your lowest latency. That's in the 500 nanosecond range, half a microsecond type of range. So InfiniBand is an open, non-proprietary standard versus NumaLink, which is SGI specific. Also, NumaLink allows us to build bigger systems. And for example, putting together a large UV system, we can put technically 4,096 CPUs in a single system image. That's what SLES is supposed to support, but there's still some scalability issues being worked out there. But if I want to go larger than 4096, then they're all going to be hooked together as a cluster. I do expect to see ultraviolets in clusters all the time as well. And then they're going to use NumaLink instead of InfiniBand. Scales to 1,000 nodes per subnet, so our largest system, Pleiades, NASA Ames. Sounds familiar. Like number 3 this week on the list is a large cluster out there. Supports low-level unlayered protocols. Again, the latest release this week, we went to a QDR instead of a DDR. So some of these numbers have changed in the past week. Key performance to InfiniBand is remote direct memory access. This is reducing our latency down from like 90 microseconds down to about 10 microseconds, just rough numbers. And in our market, that's usually large array processing that's being broken up into pieces. Those types of applications are latency critical. InfiniBand is available from several vendors in various different sizes, but the chips themselves are all coming from Mellanox. So InfiniBand is just another type of switch. Just instead of Ethernet, it's InfiniBand. And we can do Ethernet over InfiniBand. Each component, each port of a switch has a GUID, a globally unique ID. If this were Ethernet, we'd call it a MAC. A GUID is basically the same thing as a MAC. Every port is going to have a unique GUID. As the fabric manager, the OpenSM daemon runs in the cluster, it's going to go through all these GUIDs and assign them a LID, a local ID. That can be changing. That's dynamic. If something goes wrong with my fabric, there might be a resweep or a rescan of the fabric, and it might get a different LID. And in lab, you're going to be mapping GUIDs and LIDs. So this fabric manager, the OpenSM daemon, builds a routing table of lids based upon the network topology. Again, right now we've got basically three topologies: hypercube, enhanced hypercube, and dual plane fat tree. Those topologies are based upon how it is physically cabled. So there are cabling documents that say how to cable for a particular type of topology. And then you have to have the firmware for the InfiniBand switches on the CMC to be for that type of topology. So basically this OpenSM daemon, there will be two of them, a master and a failover. And then a second fabric will also have a master and a failover. So within your cluster, you'll typically have 4 OpenSM daemons running, 2 per fabric, master, failover. So if something goes down, if there's problems in the fabric, there could be a sweep of the fabric by the OpenSM daemon, and this routing table rebuilt, and lids can change. Now, not every lead node is going to be running this stuff, but it's configurable. But in ITSI OFA, there is an OpenSM IB0.conf and an IB1.conf. And in there are the various routing engines depending upon what your topology is like. And a lot of the stuff is now hidden by the GUI. Once you've got InfiniBand actually configured and running, you're going to take a snapshot with an IBT-M, and then IBT-S can do an integrity check and make sure that we don't have any duplicate GUIDs or lids. IBT is a good tool to start with to see how good shape my fabric is. So InfiniBand, we've got IP over IB as a protocol, so all my SSHs from the login node to the compute nodes are InfiniBand. Again, the user's native interconnect is InfiniBand, not Ethernet. Ethernet's just being used on VLAN head and VLAN GBE. VLAN head has got DNS, NIS imaging traffic, and on VLAN GBE to the individual compute node has got NFS traffic. One of the key things in performance here is the SDP socket direct protocol. When I open up a socket, I say I'm going to do DMA. Also in the libraries, Intel libraries, for example, they have DAPL, a direct access provider layer, where I can basically probe and find out what type of protocols can I connect to you with. Then there's iSCSI, basically Internet SCSI device. Now that was being used for SWAP. And then there's also a SCSI RDMA protocol for DMA. So the IRU has 2 or 4 IB switch blades in it. Again, I have to be careful. These numbers can change, but it was a 24-port Mellanox. Provides the interface between the computes within the IRU and also between IRUs. So of those 24 ports, some are going to the front with these IB connectors, and some are going into the back plane for what's in the IRU. And each IB IRU can have 2 or 4 blades that enable a dual plane, and 4 blades provides for non-blocking. Non-blocking simply means we got an equal number of input and output paths. So we can get point-to-point connections through it. We don't have to wait. There's an equal number of input and outputs on the switches. And within the IRU, it's called a star topology. And then outside the IRU is a hypercube or a fat tree topology. So port 7 is just showing what the switch looks like. So some of the ports are going to the back connector, back plane, to connect the blades within the IRU. And then we've got 8 ports that are going to the front, and those are to connect between IRUs. The cabling between IRUs is done by a manual, but engineering and manufacturing do have a cable verification tool. It basically checks the integrity of the cabling. So before they take the system apart in Chippewa, they run the cable verification tool to make sure it passes. And then when it's recabled back at site, they run the cable verification tool again to make sure it's cabled the way it was when it left the factory. on this just showing the port numbers. So we got 15 here and 15 down here. Blade 0, 1, 2, and 3. They just happen to flip or rotate the way they're plugged into the back panel. Now the super micro PCs, the pizza boxes, do not have onboard InfiniBand. So we have an IB HCA card that goes into a PCI bus. Again, it's got 2 ports, one for IB0, one for IB1. And traditionally IB0, that plane is used for MPI traffic, and the second fabric, the second plane, is for storage. So this card is a low-profile PCI card. It's got dual InfiniBand. Again, some of the port has gone to quad instead of double data rate. Got 128 megabyte onboard memory, and is found in the leader in the service. We are not putting HCAs in the admin node. So the admin node is not in the fabric. Number one, that's for don't need it there, so why waste the money? But number two, we usually need the ports for something else. Again, compute nodes have no PCI and no IB card. It's built right into the chipset. So that Tylersburg chipset is InfiniBand coming off of it. And then different types of cabling. You do have to be careful of not bending these cables and stuff. So all we care about here is fabric management. Each of the 2 fabrics has its own subnet manager. That's the OpenSM daemon. You'll have one instance of SM running on a lead node on some racks for each of the 2 networks. Now this is a little bit old. Originally they were not supporting failover, so I'm not sure how I can word this, but we're going to have a total of 4 daemons running. You'll have a master on one of the lead nodes and a failover on a second lead node for each fabric. There's a configuration file in ITSI OFA, the OpenSM IB0 or OpenSM IB1. And then each instance of SM on the rack controllers is either a master or a standby or failover. Again, every port that we have has a unique GUID. When you're actually in a system that has IB configured, ifconfig will show the InfiniBand, and where you normally have a MAC, you're going to see the GUID. And it's a lot bigger. There's more characters to it, more like a worldwide name than a normal MAC. So to configure this stuff, you have to go back into Configure Cluster. Now in lab, I'm going to have this all done automatically later. But I've gone into Configure Cluster, went down to Configure InfiniBand. This area, by the way, has changed quite a bit, so you have to be a little careful. I haven't looked at 2.1 yet. But here we've got configure the 2 fabrics or administer, check status, restart, stuff like that. So here I went in, and this, again, can change. I'm not sure what it's looking like right now for 2.0. But we've got the ability to configure the topology, and you need to know how your thing was cabled. I don't know of any software tool to tell me what the topology is. That's going to be a cabling type of thing. And B says whether I'm a master or a standby. In this case, R1 lead is a master. There is no standby configured at this point. So down at the bottom, I'm going to tab then from select to commit once I've set these up. So I've got Hypercube, R1 lead, so now I can do a commit. And the stuff goes into the database. So here was an example where I had my Hypercube, extended Hypercube, or fat tree. And then here I'm configuring my master and my standby. And also, again, this is marked as 1.6 only. This isn't around anymore, but the ability to specify what my routing algorithm is going to be. And that's determined upon your interconnect topology. So they've automated it now. So now I'm back to the original fabric management configure InfiniBand thing, and I do my commit. After that, I go into admin, and now I'm going to do a start to the fabric and select start, stop, restart. A cleanup is a sweep where we rebuild the routing tables in case some nodes have gone down or something. And we can also get status. Is the OpenSM daemon running, for example? So there is a command line interface here. I'm used to using the configure cluster GUI, but there is a SGI FM CLI. Do you have this slide, by the way, just to make sure?
I'm seeing it.
In your workbook. I don't know if you're following in the workbook, but...
I'm not in the workbook right now.
Okay. I'm just not sure if mine's newer than the workbook. So here with this SGI Fabric Manager command line interface, that's what the GUI's calling. So we can set up our master, our standby, or remove something, and then start, stop, get status, verify, that sort of information.
Day 420 is not this slide in the book.
Yeah, that's what I thought. I just added a newer slide since it's been printed, but there isn't a whole lot of documentation on it except when you do the SGI FM CLI with an error. So if there's a problem, the first question is the lead node up and running and have the OpenSM daemons running? There is a wrapper tempo configure fabric that calls SGI FM CLI. In some of my older releases, you had to run it more than once. The first time OFA was empty on discovery and it failed, and then you ran it a second time and it created the file and set it up. But basically, you're going to have an OpenSM_IB0, IB1.conf. Last time I looked, there was no backup of these .conf files anymore where there used to be. And then you check config OpenSMD on. So when you're running this through the GUI, you want to scroll back and look for ASCII output error. Also, you need to make sure that you've got kernel modules. There's going to be a dev InfiniBand with these different types of character interfaces to them, and I'm just listing the InfiniBand modules that get loaded. So the key commands, they're all in user bin of the rack lead controller. None of the InfiniBand lab commands, none of the IB commands are on the admin node because there's no IB there. So we have an IB nodes command to show what nodes are there, IB stat to get the status, IB status to get link rates and stuff, IB net discover, verify the fabric. Just like a trace route, we can do an IB route between two lids. There's a perf query command to get port information, and an IB diagnet to scan for devices. And with some of these commands, no output means it's all working. Silent prompt return. So there is a log. Here I was just doing a PS grepping for open. I can see where the log is. And then I did a tail on the, or head on the log. This was an older error message. This is quite a couple years old now. And we were just showing an example of something that's normal for large fabrics. You don't see that with the newer releases, but I still wanted to keep the slide in. Key command here now is IBT-S. Now you need to do -M to get a snapshot first, and then a -S. I don't know if you're taking notes, but when you see the state is in it, very good chance that the OpenSM daemon is not running. That's the first thing I look for. So here it's telling me all my GUIDs are okay. There's no duplicate GUIDs. But then it says the IB ports are not active. And again, when it's in its state, the first thing I'm going to look for is, did the OpenSM daemon get started? There's a command OFED_info to tell you about the version levels that you're running. There's an MST Flint, give some diagnostics, and also IB version. So here I SSH'd R1 lead, and then I SSH'd to the IRU's CMC. Now earlier I came in through the serial port. This is coming in through the Ethernet. And then when I'm on the CMC, I can do IB_version and get version information. But that's not needed anymore. There is a firmware rev script that will get everything for you. The last I heard, once we get larger than 32 racks, then we need a meta router to connect between the racks. As far as I know, they're still using Voltaire switches for that. And these are professional services. And once you have Voltaire switches, there's grid vision software that can give you a web GUI to the Voltaire switches. So, I'm going to give you a quick break here, and then we'll come back to do the last customized piece. But in lab, after today's lecture, we want to probe the fabric, run configure cluster to actually configure the OpenSM daemons, and then do some inventory and troubleshooting. And then some of the URLs there. Any questions right now?
Not at the moment.
Leave it more for when we actually get stuck on the machine. I'd like to take a 5-minute break, a real quick break here, just so you can clear your head, and then we'll do the last customized module. Okay?
Okay.
All right.
are we back yet?
I'm here.
Connie? Kevin? Give them another minute or two. So Megan, what site were you involved with?
Well, as I mentioned, I'm a very new hire at RHEL in Aberdeen, Maryland.
Uh-huh.
There is a new, meaning within the last year, SGI Ice installed there, and I'm part of bringing on staffing to administer on-site needs of that cluster.
Sure. I was at ARL last summer for the ICE admin class.
I said my experience had been mostly with available style clusters, little pizza boxes in racks, and we did, Pixie boot and all of that to push things out, but it was all open source, non-proprietary tools. So all the tempo tools and the C-Power, C3 stuff, well, C3 was open, but that's not what we use. So that's all new.
They're all layers on top of Oscar, so.
And we did Pixie boot.
Connie, are you back yet?
Start pre-install and post-install scripts. That was at NASA's Goddard Space Flight Center where I had been previously.
Who just joined?
Hi, it's Connie.
Okay. Kevin's still showing on the WebEx. Kevin, are you around yet? Did I hear Kevin come in?
That's me, yeah.
Okay. So I think everybody's here. So I'm going to talk customizing now. All of tomorrow pretty much will be on customizing. I'll give you some milestones, but I'm going to come back through this module tomorrow and repeat it. So once you've done the InfiniBand configuration, you really do not have a user-ready cluster yet. So everybody able to see the customizing module? So one of the things we're going to do in customizing is add things to the repository. During lab, you can choose whether you want Torque or PBS Pro. We're also going to put in an SGI dev kernel so that we can get profiling and hardware counters working. We'll also be putting in other flavors of MPI. So the first part of the lab is going to be to maintain that repository that I looked at just before break in TFTP boot, and to be able to use Creepo and CInstallman to rebuild images and make your own custom RPM lists. Engineering makes these lists as small as possible. For example, C compilers may not be there. Includes may not be there. Now I've got one application that does X11 graphics, and you're going to need to have the X11 development packages loaded. So there are RPMs that have to be added in. In SLES 11, the GNU Fortran stuff got moved off to the SDK. So these things are going to have to go into a customized repository directory. After we get an image built with the additional RPMs added, and again, that takes about 15-20 minutes per image, and I do want yum problems in there, for example, conflicts or dependencies, things like that. After the RPM, or after the image is built, then we want to configure the network services. The login node does not have ETH1 to the house configured yet. We're also going to configure the network address translation, NAT. So there are IP rules that are on the service node. We also want to configure NFS, My compute nodes are mounting the login node, but they're also mounting DMZ server from outside the cluster to make sure that DNS is working correctly. So NFS is going to mount directories that are inside the cluster and outside the cluster. NIS is where everybody gets stuck. No easy solution here. Master slaves require a pushing of maps around, and that doesn't always work smoothly if the fabric isn't up, things like that. So I'm expecting everybody to get up to NIS today, and tomorrow morning, first thing, will be NIS problems. Also want to be able to get the remote desktop configured so that my users can have a desktop instead of just SSHing in. Now, to save you time, I've already got some custom scripts. So they're templates for you to look at. If I have to run a tuning class and get into profiling applications, and I've got 4 clusters to build, I don't want to do it all by hand every time. I'd like a robo-inst type of thing. Hit enter and walk away. On George that I was just looking at, I did see some of my post-install scripts. So my sample post-install scripts are off on the DMZ server, and you're simply going to put them in place. And I'll show you that in a live demo here. Also on a per host customization, customizing scripts like setting up the module command. And lastly, you're going to be working with CMage to maintain your compute node boot images. So I'm hoping by the end of tomorrow, you're sending me email to say my cluster is ready for users. And then I'm going to log in and say it's working or it isn't and point out problems. So pretend I'm your end user by the end of tomorrow. Page 5.3, the first thing you're going to do in customizing is to add images, add RPMs to the images. Now again, there is the ability to save typing because the RPM lists are in the DMZ server customized directories. The lab also has them spelled out, so you can either edit them and enter them by hand or use pre-typed versions. Of course, editing by hand introduces errors, and I like errors. I'd rather see them now and let you catch a typo. So once those RPMs are added into the repository, and then with cinstallman you rebuild the images with those RPMs added, then we're going to customize the compute node. We need to set up the route out of the system. We need to modify FS tab. We need to take care of user authentication with NIS, and also push NIS maps to the lead and the compute nodes. And I also want my module command to know where my additional add-on products are. So there's an init.modules path that we're going to modify. I also need to modify itsy-resolve.conf possibly. We'll take a look at that. Usually to put in the house domain search. And also third-party products. So my customized scripts, if PBS or Torque are there, we'll automatically configure them. We'll configure PBS mom. And we're also tomorrow going to be loading Intel compilers and Intel MPI. So I'm hoping by the end of tomorrow we're actually running MPI applications. That's the usual milestone. End of the day, stuck in NIS, into tomorrow, hand off to users. The lead node, we're going to have to worry about user authentication. And I should add in a note here, we also have to worry about InfiniBand. Any of those configure cluster changes I made are on the current root, but if I re-image the lead node, it's all lost. So I have a customized script that will rebuild the InfiniBand stuff when I re-image with Discover. Lastly, the service node, we're going to have to configure ETH1, give it a public IP, and you can, within the SGI network, ping, like George 1, George 2, George 3, to get your IP address, and it is in the lab manual as well. We're going to have to configure NAT, which is some IP table stuff, and a couple of kernel modules that have to get loaded. And we have to configure the route out of the system. We're going to make changes to FS tab. We're exporting our home and SW for our additional products. And we also have to modify modules.path. And I want the remote desktop working. And another thing is, this isn't needed as much anymore, but in older releases, the host name of the service nodes was just service 0 through whatever. So I had hooks to change my login prompt to be the host name that I wanted. There now is an option of actually changing the host name from service 0 to, for example, George 1. Historically, there were still bugs or problems in that area. Also on the service node, I've got to get user authentication working. A few minutes ago, I simply added myself to the ISI password, ISI shadow, and then pushed them out by file. But the lab has it using NIS. We might have to configure the web server. By default, Apache is going to be listening to ETH0, which is inside the cluster. It's not on the public subnet. So if I have people that want to get to a web server on this thing for whatever reason, I have to point the web server to the public IP, not to the internal subnet. I'm also going to have to muck with the menu.list. These clusters are going to be needed next week for a application tuning class, and I need Perf Suite, PS Run, and profiling tools, PFMON, working, and that requires an SGI dev kernel. So in our customizing, we're going to add that SGI dev kernel into our repository, and it will be available in the image. But menu.list only supports one kernel, so we're going to have to edit menu.list to be able to choose whether we want a normal kernel or the SGI dev kernel. And I'm hoping by Friday I've got Perf Suite and PS Run working on the 4 clusters. I'm taking care of one, and then each of you have your own. Also on the service node, we're going to have to deal with PBS Pro. We're going to deal with the license manager for PBS, and also load the Intel products. Any questions on that?
It just sounds like a lot.
So it's a lot of tweaking. The thing is, I don't want to do it over and over and over again. I'd like to do it in one place, and that also documents the customized changes. If I upgrade to 11 or /11 SP1, if I do this properly, it'll all be documented. I won't have to go in by hand and redo things over and over again. The more I do by hand every time, the more chance of typos and errors. So I want to automate all this in a script. Any questions? So, crepo is a command to maintain the repository. It's basically a layer on top of Yummy, and Yummy is a layer on top of Yum. So in Lab, you're going to create your own directory called My Packages and put in custom packages that are not part of a distribution. For example, you're going to put in PBS or PBS or Torque. You're going to put in MBAPIDGE, SGI dev kernels, things like that. Then with crepo, you're basically going to build this repository. So crepo-add, where that directory was, and then the name of that repository. And when it's done, in that My Packages directory, there will be a repo cache and a repo data subdirectory that says this stuff is known to the repository. Purpose of the repository is tight control of the RPMs, so somebody can't just accidentally drop an RPM and change it on me. So with crepo, I can add to the repository, delete things, show what distros I have, show update servers. Basically, this repository is what you're going to update and then push those updates out to all the nodes in the cluster. So basically, that repository is going to be a mirror of the Novell and SGI update repositories. Now, there is an issue there that if I don't have a modify on crepo, so I still may have to do a yummy-prepare repo to update the repository, to rebuild it. I haven't tried that in a while to see if Creepo will handle that yet. But there are traditionally problems in this area. Maybe I forgot to add a package, I come try to add it back in, but I'm not able to update the repository with the one package I missed. I'm going to wait for you to hit that problem before we deal with it more. So the next page 5.5 is just showing the syntax. So I can add stuff to the repository, and this would include the SDK, things like that. So --add and then --custom is the name that this repository product or component is going to be. We can delete it, we can show what's there, show updates, and re-export. If I made changes, I can re-export my repositories. After I've built that repository, then this install-man is what's going to create my image. It's a wrapper to something called make-si-image and something that used to be called yum-image wrapper. Make-si-image is still there. That's a system imager command. So install-man just makes it easier to use. install-man is going to include all the directories that are part of the repository. So with install-man, just like you did from configure cluster, create an image from scratch. Again, that takes about 15-20 minutes per image. I can copy or clone an existing image. So maybe I've got an image that's working, I want to freeze it, and then create a new image that I'm going to try my next level of changes on it. I can recreate an image. I can use images that have been created by some other means. For example, I could put in CentOS or something like that. Delete images, show what images are there. Again, install-man is how I apply updates. So with install-man, I can update my images and get all my patches into the images, and I can also update the running nodes. Now, if there's a kernel change, it may require a reboot on that particular node to get to the new kernel. I can assign images to nodes, and I can choose what a node should do when it reboots, whether it's going to image itself or boot from disk. Again, I still need yummy prepare repo to update the repository. Also, if you have time in lab, you can capture an image. So with make-si-image-get, I can go off and get the image and put it back into my images directory and reuse it to image again from. So I'm hoping that you get a chance to try that. And I do have to be careful here because it looks like the editor turned 2 dashes into 1. So watch out for syntax problems where the editor's taken 2 short dashes and turned them into a long dash. So the syntax for install-man, there's no man page, but again, create an image, clone it, recreate it, use an existing image, name of the image, and the RPM list that you're building from. Or delete an image, show images, show nodes and what they've got, update an image, refresh an image to include all packages. So I don't necessarily, in lab, you're going to build the image from scratch. But you don't have to do that. I just want you to do it to be able to do it. But you can also just say, I've got images out there, instead of rebuilding from scratch, let me just add these things. And then there's also the ability to update an image. And I've got some line wraps there, but there's a couple of other options there. Don't forget the BT-refresh. BitTorrent-refresh is an important one now. So I'd refresh image, yum image, update the node, refresh the node, perform operations. So I can do a yum node install package name. So it's basically going to run yum on a given node and take care of all the wrapper type of stuff for directories and where the repository is. Assign an image to a node, what to do the next time we're going to boot, and as I just mentioned, the refresh BitTorrent. So I'm going to leave some of that to actual lab, let it sink in. So in this example, I basically put all my packages that I'm adding into my packages, These packages are off on DNZ-server. And then I added it in the repository, and it's called My Packages. Then I did c-install-man and created an image, called it service-new, and then pointed to an RPM list. Then I did a power off, and then I did a discover, and when I did the discover, I said image equals, and I used the new image name. This is the old way if you're Tempo 1.1, 2, or 3, and I wouldn't be running Tempo 1.3 or earlier. But in the older days, you'd do a yummy and then make SI image and then post-process. Some extra steps there. I'm just skipping over that. That's not relevant to us anymore. So, our service nodes. We need to configure ETH1. After imaging, you log into the service node, and then you can run the YAST and configure your network card. Now, a couple of you got bit by this, but on the admin node, ETH0 is to the house, and ETH1 is to the cluster. On all other nodes, ETH0 is to the cluster. So on the login nodes, service nodes, ETH1 is the thing that you configure for the house. So you're going to set up the static IP, set up the net mask. Do not change your host name via YAST. You've got to do it through this cadmin -- host name. That makes sure that it's changed everywhere throughout the cluster. And you got to be careful here. You can't go in and tweak ITSC host files. ITSC host files are changed on boot. They're generated when you boot the node. Also, don't go in and change the name server when you're in YAST trying to configure ETH1. We'll get into where the name servers are running and stuff later. Also add in the public gateway to ETH1. So there will be steps on that. This is the point that you're actually going to be, debugging and rediscovering over and over until you get things working. You will get sick of Discover by the end of tomorrow. So here I just went into YAST. I selected my second port now because that's the public. If you go in and see a 172, that's an internal subnet. You're on the wrong network interface. Again, only the admin node has ETH0 to the house. Everyone else, all service nodes, would be ETH1 to the house. So I down arrow to the second interface, edit, and then I'm going to stick in my IP address and my net mask. Then go off to my name server, stick in my name servers here. Stick in, this is a little bit old, but the domain name. And then the default gateway. Now, beginning with Tempo 1.4, there was the cadmin -- set host name. If I rediscover, that's lost, but that goes into the database and changes, for example, service 0 to be called George. And then when you reboot, everything will think it's George. And at that point, there will be no service 0 anymore. But if I rediscover it, George is lost and service 0 is back. And there have been problems, I don't know, on 1.10 or 2.0, but historically Console and CPower have had problems with this set host name. So it had been discouraged in the past. I have not tested it lately. Feel free to try it. It is in the lab. So, after we got ETH0 configured, we have to configure network address translation. Again, the blades can get to the house, but the house cannot get to the blades. That's what NAT is doing. So it allows my compute nodes to get outside the cluster. Now on login and gateway nodes, there's an opt SGI doc setting up NAT, and there's a README file. That README file is really just a script. If you source it, it sets it up. It's going to load the appropriate kernel modules, set up IP forwarding, and IP table rules. I always wanted it to be a script name, but they didn't want to call it a script because then they said they might have to support it. So it is a file called README, you just source it. But in my lab, I'm going to do that automatically through my own custom script. So besides on the service nodes, I'm going to go to the compute nodes and go into this per host customization directory and edit SGI static routes to add the gateway. Then I have to re-image and reboot, and that means rediscover. Have to be a little careful here. Nowadays, when we delete something from the database, it does not delete the IP address. If we rediscover it, we should be getting the original IP that we first had. But for a while there, once they deleted from the database, they threw away the prior IP that it had, and there was no guarantee on a rediscover that it got the same IP address. That's not a problem that I've seen anymore. But always be careful of that. If you re-image a service or a gateway, make sure that it's got the compute nodes still have the proper IP address for that gateway. And NAT still needs DNS to resolve hosts and domains. Any questions right now? Kevin, you still there? Connie?
Yep.
I'm still here.
Okay. The next thing is automatic, pretty much, configure-cluster, set up our DNS. Now, a lot of this traffic is going off on Ethernet and VLAN head and VLAN GVE. We're trying to avoid DNS traffic on the fabric because we want InfiniBand to be used for our payloads, for our applications. So compute nodes do not have named running, they just use resolve.conf, which points to the lead node. Now one of the things here is scalability. I do not want 50,000 nodes pounding on one named D. So basically each lead node is the name server for that particular rack. So on the compute nodes, there's no named D and no named.conf. And you have to go into per host customization to modify the domain search. The lead nodes then point to the admin. Some sites change that. They don't want the admin on the actual network. So then they go off and change things to use maybe a second service node or the login node itself. But the lead node, ITSI named.conf, will have a forwarder. And you should be able to, this future should be resolved right now. Being able to manage the domain search that's there as well. Service 0 has resolve.conf pointing to the admin and the lead. So if the admin's not there, we can go to the lead and hope it's cached there. But again, everything's going through the admin node. If the admin node goes down, DNS may be able to resolve things out of caches within the cluster, but if it's a new lookup, it may have to go outside the cluster. And if the admin node's not up at the time, that could be a failure point. So the admin node then points to the public. And it was during the first boot that we set up our house DNS and domain searches. You always want to check to make sure those are accurate before you start imaging. Otherwise, you may have something that is wrong throughout the cluster. We're going to be testing that in the next day. So 520 is trying to show in Temple 1.10 what the admin node, the servers, the rack lead, and the computes have for their host file, their resolve.conf, whether they're running named D. So the admin node is master, and the lead nodes are the slaves. And then what they have in var lib, and then their ITSI named.conf forwarding. And lastly, DHCP.conf and what his has. Now there was an inventory step. We didn't get time for it, but in the right after the discovers and playing with cPower and console, there was some inventory stuff to kind of trace through and see what these look like. Okay, 521. This is worth having a hard copy of. I'm only going to go a couple more slides. I do expect email and questions in this area. So this is trying to show the flow of an image and all the different places that I can make changes to the image. So I got a number here, 1, 2, 3, 4, 5, 6, 7, 8, 9 different points that I can make changes to my image. So it's kind of a cheat sheet to put it all together. So we start off in the upper left my admin-install.iso. I was the one that did the network PXE boot yesterday and left it where it was already on the admin node. But within that ISO, we have Tempo, some SLES, some ProPack, and Oscar. All that's in as small an ISO as possible. So when I DVD boot, or in my case, network PXE booted, that thing got rsynced onto the admin node, and I left everybody with it finished with the syncing, sitting at a busy box, and then you did a reboot and took care of the first boot stuff. After first boot was done, we then ran configure cluster. Now configure cluster went off to an ISO, so in our case we pointed to the DMZ server for an ISO. And it took maybe 5 minutes or so to copy that ISO into TFTP boot distro. Then we also did ProPack and put it in there. And the first custom change you're going to do today is make a directory called My Packages and then put in PBS Pro or Torque, MBAPITCH, an SGI dev kernel, some of those sorts of things. So that's the first place you get into customizing. Do not put custom packages in distro or SGI. They get wiped out on updates and upgrades. They get stepped in. So if I were to do an upgrade, that might actually move distro to old.distro, create a new distro, and then remove the old.distro. So do not do any sort of custom packages within the distro or SGI directories, because they will get stepped on, rotated, and replaced. So I'm just creating my packages. You could call it whatever you want. Then in configure cluster, or today by hand, you run the cinstall man, and it's going to take the distro, SGI, my packages, and also ITSI opt SGI RPM lists. It will take the RPM list and build an image. All of our images, and I think it was Megan that was asking, all of our images are in varlib system imager images. So right now we have 3 images in there: the lead, the service, and the compute. And all these were created by make.si image. So I drop in my packages, I add them to an RPM list. We don't have to worry about it, but there's a post-process script that then leaves everything in varlib system imager images. Now I can modify those images as well with cinstall man. So the third thing I can do is, for example, I can do a cinstall yum image install PCP. So I can fire off yum commands that are going to make changes within the image. So I can install, erase, that sort of thing. I can also apply updates to the images with cinstall man. So cinstall man is a wrapper into the image itself, and it's chrooting, things like that. But it's also making sure things like /proc are mounted or unmounted correctly. Normally when you're chrooting, they don't get mounted unless you're explicit about it. The fourth place I can make changes is actually chroot into the image and then do like a make dir /sw. Trouble is, anything I do in a chroot is not documented. It's being done by hand. And then I forget what I did. So what we're going to do is use up here a post-install script. So anyways, number 4, I can chroot into my image. Once I have my images, I have a discover command up here, one for the rack, one for the service. So when I do a discover, they're going to go off, and there is an overrides directory that allows me to replace files. So I could drop in a license file or something like that. So this override directories has a file tree to it, and I can replace things in the file tree with whatever's in overrides. One thing I cannot replace, though, is menu.lst. That's generated later. Again, image node, temp si-monitor.log will say anything that's going on in these 3 things. Also, scripts that are in pre-install run before I do my mount makefs chroot. So pre-install is what actually, for example, does the partitioning. And then once we partition, once we've done our makefs, we then chroot into it, and post-install scripts are running in that root environment. So these post-install scripts are what we're going to use for customizing. We've got a number scheme for the order, node name. I can use wildcards, and in this case, I can say service as a wildcard or service 0 just unique to service 0. And then I also have a R1 lead script. Any errors in these scripts that you've got are going to end up in simonitor.log on the system you're imaging. So this is where you're going to get worn out in the next day when you're trying to get these service and R1 lead scripts running perfectly so that if you image a node, it's ready to use. And lab is going to have you do a change in every one of these 9 spots. Also, on boot, sbin conf.d are my SUSE boot scripts, like should the machine be registered, get updates, things like that. And there's also InfiniBand SGI conf.d. I'm using that in my post-install script as well. So there's a lot of stuff in the SGI conf.d, like network socket sizes, ulimit settings, things like that. That's the 7th place you can make changes. So I've got my post-install script actually creates a conf.d script. 8th place, once I've got the system imaged, I can SSH to it and make changes there. Trouble is, if I have to re-image, all those changes are lost. I'd rather make sure that when I do my discover, I don't have to remember to do 15 other things to make it usable. I'd like it all automated. Now, another thing to warn you about here, compute nodes do not use discover. Compute nodes do not have an rsync root disk. So for compute nodes, there's BladeMonD. And BladeMonD is what did our imaging earlier today. And BladeMonD can also be kicked by a cimage --push-rack. But again, you got to be careful about the BT refresh to make sure that your BitTorrent tarball is the latest if you've made any custom changes. So after every custom change, a cinstallman --refresh-BT is appropriate. Now, cimage, when it's pushing there, is putting a var lib SGI per host directory in the lead node. So after the 8th place, I kind of missed it here. The other place that we can make changes is per host customization. That's for the compute nodes. Those are actually running on the lead node when it runs. And then lastly, once I've got a node's root for service nodes, I can copy that root, rsync it with a --get, and then that puts it back into the images directory with a new name. I know it's going to take a while to sink in, but are there any questions right now? I'm going to have you play around and do things in each one of these 9 areas. Again, what I'm trying to do is make sure if I have to upgrade or whatever, everything I've documented in my packages, RPM lists, post-install scripts, and per host customization scripts, it's all documented and easy to upgrade and catch what my custom changes were. By writing them in a script, I'm documenting the changes as well. Anybody got questions? So, Tempo has its own customized scripts. During boot, there's an sbin conf.d customer configuration script that's then going to go into the InfiniBand SGI conf.d directory and run those. And different nodes have different conf.d directories. So I've got the admin node, I've got a service node, and I've got a compute node visible here. So these are run on every boot. In here, for example, what my ulimit for memory lock and stuff is, my network socket sizes, things of that sort. Mentioned grub, that overrides directory, said overrides can replace a file or drop in like a license file, except for the menu.list because that is generated on boot with grub configuration. Limit on core files, things of that sort. Again, once these nodes are discovered, it's the yum or cinstallman yum node install RPM name. So overrides pre-install and post-install are used during discovery. This is where I'm going to put all my custom stuff. Not used for compute nodes, they're using CImage. They don't have a mini root rsync concept. So in varlib system imager overrides image name, but again it won't work for the menu.list that's generated later. Then we get a master script that's actually going to do the imaging. Then there's a pre-install before we do our make part, and then a post-install after we've cherooted into what we've parted and make fs and cherooted into. Again, errors will be in temp si-monitor.log, move to root on success. And everything in post-install is in a cheroot/a environment. If the script fails, if your post-install script fails, you're going to fall out of the cheroot environment. You'll get a prompt and say, well, that file isn't there. That's because it's not in the mini root initRD. It's in the actual /a root. But because of the failure, we fall out of the cheroot. So 524 is an example. I'm going to show you this live on the system. But I've got a post-install script, and there are /temp/variables.txt with variables in it. So I'm grabbing an image name out of there. Then I'm creating in conf.d a local site.local type of script. So every time we boot, conf.d will run this site.local. And in it, I'm setting, this is NAT, I'm setting IP forwarding on. I'm setting up my IP table. So there's this IP tables config as a vanilla IP tables rules list. And then I have to load in this IP contract and IP NAT RPM. Note I've got pipe/bin/true. When I'm doing the mod probe of these things, they don't match the BOL kernel that's running. So the first time I boot, while I'm in imaging, these will fail. But then once I'm booting on the production kernel, they will work correctly. So this pipe/bin/true is just making sure that if the kernel modules don't match the BOL kernel, I can keep going. I then chmoded that site.local script so it would run the next time we boot. Also, this thing here, var run post install, is something I created to know if the image has been imaged already. If I do a get, and if I capture an image out there, I do not want to run the same install script on that thing. For example, the next line here says I'm going to append the FS tab. If it's already in FS tab, I don't want to append it again. So the first time I image, I create this var run post install, and then later I can check to see, so here when I'm done, I touch it. And then the second time I come through, because I've done a get and have captured an image, that image has already had post install run, this is going to say, oh, you've already run post install, so it will skip over stuff instead of appending over and over and over again. So that's what the next slide. The var run post install is a flag I created. So with make si image -- get, you can capture an image from the leader service nodes, started in Temple 1.3. I have to be careful. Last time I was looking, it did capture everything that was mounted, like home. And I just want to capture the golden root. So in lab, what you'll do is you log onto the service node and do this si prepare client, point to the server. Then on the server, on the admin controller, you'll run the make si image -- get, name the client that you started the prepare client on, and then what you wanted the new image to be called. Then you have to run post-process SGI image on that image. And then after that, you can do a discover on it using the new name. But again, remember, post-install runs it again, So you need to handle things. So for example, a makedir might fail, but if I do a makedir-p, that won't fail if it already exists. .526 is for compute nodes now. So CMH --list -images will show what's out there. --list -nodes will show what the image the node is booted from. And then we've got a create image --clone capability. And you can also use cInstallMan as a chroot image wrapper to do things inside the image, like a yum command. So modifying the image, we're going to add RPMs, and then do a, for example, cInstallMan yum image install name of the RPM. So use yum because it knows where the repository is. Don't use RPM. When you're done in the chroot, you got to be careful. Remove any ISOs or packages. I had somebody chroot into an image, copy all of SLES into it, 4 gig, and then they didn't remove it, and then when they did a push rack, it pushed that 4 gig ISO out 64 times. So we had like 256 gig, 64 copies of SLES sitting there. So you don't want to do that. Clean up anything you can. You can hit quotas too. There are disk quotas by node on the lead node. We'll talk about that Friday. You also cannot do a push-rack to an active node. Again, push rack is going to build the slash and the var on the lead node. And after we're done with the push rack with this new image, we do --set, new image name, kernel name that we want, and the node that we want it working on. And the next time we reboot, we use this image. So CImage has some options to add to the DB, delete from the DB, update the DB, delete a rack, or delete an image. Delete rack is meant to save space on the rack lead controller, but we still have the image on the admin node. So if I had 10 different images sitting out there on the rack lead controller, I could be using up too much disk space. So I can delete them from the rack, but still have them on the admin. Whereas a delete image will get rid of them both on the admin and the lead node. And then you'll have to recreate the image from scratch. So earlier, forget who was talking about it, we could tar up an image, save it, add it in late, untar it back into that images directory, and then do an add DB to get that image back into the database. And then should be able to discover with it, assuming the image is bootable. So customizing the service and lead nodes will be a post-install script. Customizing the compute nodes is this per host customization directory. And in there are some pre-built ones. There's a SGI FS tab for the FS tab. There's one for resolve.conf to change your domain search. There's one for static routes to change your route from the compute to the public. These scripts run on the RLC. Also, watch out. People will copy and make a backup of these things before they change them, but a .bak or a tilde, those things will run after the original script. So somebody will go in and edit static routes, but there's still a static route .bak. So then when they do their CImage push rack, it runs static route, but then it runs the backup, and the backup undid whatever you had in your original script. So be very careful about that. A lot of people get bit by that. It's going to go through this directory alphabetically, or normal file search. So you do not want to have .backups or anything that's longer than the original file name is going to get picked up last. So copy them somewhere else, like your root directory or something. If you do need to grab a new one, there's no easy way to just pull an RPM to replace them. You really need to find a cluster that's working and copy it from a working cluster. It's not a simple RPM that you can replace on. So this is the per host customization script example. So we had a post install and a per host script. So in here, the first thing it's doing is a sanity check. And then I'm getting my top directory. Now passed into these scripts, $1 is going to be my root directory. So I'm echoing $1 and then getting rid of the var lib SG, or pasting on var lib SGI root FS to get to my top directory. And then in that top directory, I'm making /archive. So there's going to be a mount point in /. Then, to avoid multiple times, I'm saying, do we have SW module files in the modules path? If it's not there, then we're going to echo SW module files into the .modules path. That way, the compute nodes know where to find the modules for compilers and stuff. Then the script is echoing ICE into the NIS domain name, pointing to the YP comp for the YP server, and setting up ITSI group, ITSI password, and ITSI shadow to say this is NIS, and then check config YP bind on. Now, frankly, that YP bind on is dangerous because if it doesn't connect to the master, it may take you 5 minutes to be able to get through a login. Sometimes I prefer to do YP bind by hand. Now, my plan is tomorrow morning to walk through NIS and get it working. Almost done. So our default NFS options, again, the compute nodes mount /ROOT, which is root's home, ITSI, and var. These are mounted from within initRD. The compute nodes have temp and var temp linked together and in tempfs. Blades can use NFS to mount the service nodes. I'm using service 0-IB1, not 0, because 0 is for my MPI traffic, and I don't want I/O to interfere with my MPI traffic. And then compute node mounts an IP address outside the cluster, assuming we have NAT set. And that's about it. I am going to stop with lecture here and just go to a quick demo. But typical pace, first thing tomorrow, we'll deal with problems and then finish up with NIS. So it's walking through NIS. We'll add users, get the remote desktop configured, and then some C-admin stuff. Talk about multiple slots and things. So your exercises for the today after IB is to modify your RPM list, build new images, and then test them. Then configure ETH1 and save settings. And actually, we're not going to do that. It's already been done. I'm not using the overrides directory anymore. I'm going to have to fix that. One thing I got to warn you: when I create new images, the overrides directory is not populated from the older image. So if I go off and drop something into an overrides directory, then I create a newer image, I got to clone the overrides directory into that new images directory. If I forget, these NIC interface settings might not be there. Again, you're going to configure NAT, configure NIS, and that's where you're going to stop for the night. So, I'm on George. I'm going to go into var lib system imager. And in there, I've got images. And there I can see my service image in this case. What's going on here? I don't like this. I thought there'd be more images in there. And a second. That little flow chart, image flow, is worth having handy. So I was expecting more images in there, but I'm going to go on here with var lib system imager scripts. Okay, so I'm back on my system. So I see a service image there, but I don't see a lead node image there. In fact, we had rebuilt it, but let me go into var lib system imager. And we've only got images there. Let me see. Oh, that's why I was on the login node, not the admin node. My mistake. Var lib system imager. Now we've got what I was expecting. There's my images, my overrides, my scripts. So I'm going to do an ls on images, and there I've got some that are already from a prior class. I got my original compute, the original service, and the original lead. And then they also created a new image, a clone image, my image, some other examples. Now these images are chrootable, but you usually do have to worry about mounting /proc and /sys. That has to be done by hand when you're going into them. I'm going to go into the scripts directory now, and in there is a post-install and a pre-install. There shouldn't be anything in pre-install, let me just check. And it's a harmless script. In fact, if you're really paying attention to me, I can go into that harmless script, put an exit 1 in there, and basically go into a rescue mode with it. If I have trouble doing a parted or something like that, I can stop the imaging process, go into that script, put in an exit 1, and basically will fail in the pre-processing script. Then I can poke around with parted, remake labels, things like that. It's almost like a rescue mode. But the one we're going to be using is post-install. And I go in there. There are already some there by default tempo, but these have been added by the prior student. Now, let me see, SSH to DMZ-server. You can either NFS mount DMZ server or SCP to it, but this will be in the labs. In archive IceCast lab files, there's going to be an RPMs directory and a customized directory. So we're going to be using customize 1.10 and RPMs 1.10. So in the RPMs 1.10 directory, I've got kernel modules needed. There's my OpenMPI, there's PBS, there's MBAPICH and MBAPICH2, and my SGI dev kernel. So these are the RPMs I want you to add to your image. Now, if anybody wanted torque, send me email. There will be torque RPMs, but they're in a different directory. I'm going to make a note. I need to get torque in there. And the class last week, it also looked like the SGI dev kernel was broken. So I may end up replacing the SGI dev kernel as well. So those are the RPMs. Then in the customized directory, first of all, I have the RPM lists. So instead of typing it out, you can simply cut and paste the RPMs that I want in a given list. Okay, and they're spelled out by hand in the lab, or you can cut and paste. Also then, I have my, for /10 in our case, the lead node script that's going to set up InfiniBand. And then here's my service script. So if I do a more on this one, this is going to be that 99service0.local script and a whole bunch of diagnostic information at the top. We do source the variables.txt to pick up information from the imager. And then the first thing it's doing is figuring out what's my MAC and then configuring and creating a MAC configuration file and it's going to go through for each of the hosts. So when I run this one script, it will figure out which of the 4 clusters the script is running on and appropriately configure ETH1 for that particular host for that Mac. And I've got 4 in the DMZ and 2 called Sunny 1 and Sunny 2 that are in this. And also in the process, I'm also adding my route and adding the Apache IP address. What's the public host IP address that Apache web server is going to be listening at? After the Ethernet, there is my NAT. So I want you to look at these scripts. So I'm basically what I had in the workbook, creating a 99site.local, setting up my IP forwarding, getting my IP tables, and then loading the kernel modules. Then I chmoded it, did a diagnostic to see what's in there. Then this was my little hook to say, have we run post-install yet? If not, I'm going to go in and add things into FS tab. Now, L3 George was the older name for it. It's now called DMZ Server. And don't be afraid if there are bugs in here. Send me output, things like that. I generally do want to have some problems in this area. But after FS tab, then I'm doing my exports. Then I'm making my mount points, turning on the NFS server. There was a hook there for re-exporting NFS. There's a user NFS package out there now so that the login node can mount something outside the cluster, and then the cluster can mount what was mounted on the login node. But I'm not using that package anymore. Support has dropped for that package. It creates conflicts now when I try to use it. But that's just a leftover from that. Then I'm setting up my remote desktop. I do have to muck with a few things often, ITSY sysconfig. And then I was trying to, this is not working yet, but trying to set up remote VNC for X11. Then I'm adding module files in here, turning on Apache, turning on NIS. Again, it's still going to be a problem actually starting NIS because there may not be InfiniBand up and running at this point. I'm also doing some stuff to turn on CSA accounting. And then when I'm done, touching post-install to say this has been run once. Also in my script, I'm setting up array services. We'll talk about that end of tomorrow. And then I'm also setting up some DAPL, setting up my host name, and here's my prompts if I wanted to change my prompts. And then lastly, saying if I've got PBS loaded, how to configure PBS, or there's an LSF one in there as well. If torque is loaded, then set up torque. So that's an example of the service node. Again, I'm just trying to save you time, and then I hope that there are a couple of debug problems in there for you. The other one then is the X local. This is going to be for your per host customization on the compute nodes. So this is for compute nodes going into per host customization. So here I'm doing the sanity, CM, and then I'm figuring out my domain name. Here's where I'm actually figuring out what my distribution is. Am I SLES or not? Now my script is only written for SLES. And then I'm adding into FS tab, and note, here's where I'm setting up the size of my /temp. And then I'm adding in the other mount points. Trying to figure out what my top directory is, and then making my mount points in the top directory. Setting the sticky bit for temp. That's really not, oh, it's in boot.local. So that'll get set on boot. I was going to say temp has to actually be mounted for that to mean anything. I'm also setting up my resolve.conf, adding in a domain. And then here's some stuff that's monkey business. I'm trying to figure out my route, going off to the admin node to figure out what's my route's IP, and then setting up my route. So that's automating it there. And then I'm deciding if I've got the SW modules file loaded in my .modules path. If it's not there, then I add it. Now remember, this script is going to run 64 times, one for each node. And I don't want to have that in the I don't want to have it in modules path 64 times. Then I'm setting up NIS, but I am not turning it on. I need to be able to debug it still, because if YP bind doesn't bind to anything because it's not there yet, we usually image the lead node, then the service node, and therefore there won't be an NIS server there yet. So I've got that commented out. Otherwise, trying to log in will take a long time. I'm also then setting up my array config. Now here the problem is I have hard-coded the nodes. So I was just saying that's a bad thing to do. I'll get into arrayd.conf tomorrow. Then setting up CSA, DAPL, and then if I'm PBS or TORC, setting up the necessary things for them. And then that's it. Okay. Now the intent for me was to actually run this setup script, and it would do everything for me. So if I image the node, I would run setup, it would build my repository, build my images, and then when I discover it's already got my changes in it. I want to be able to build a cluster within about 2 hours, 2 to 3 hours, which includes all the discovery, all the make SI image and stuff like that. If I got to build 4 clusters on a Sunday, I do not want to have to do it by hand and then debug all my typos and mistakes. I kind of went through that quickly because you're going to hit it, and once you get stuck in it, that's going to be more of the learning opportunity. Anybody have questions? Are you still there?
Barely.
There.
Any questions?
Oh, got to do it.
Yep, that's what I say. I can talk and talk, but I think it's better for you to work your way through it. That one drawing showing the flow and all the paths is extremely useful to me. And you're basically going to make changes and learn how to take a change in each area. But I do hope Discover's fail, that there are problems in the scripts such that you have to go in and debug some things. But generally the debugging starts with NIS. Some classes, they don't get far enough because they're behind, and then I just use ITSY password, ITSY shadow, and push them. But at the end of the week, I usually try to clobber your cluster except for the admin node and see how quickly you can get your cluster back and ready for users. And some of the top people basically can get a cluster back together in about 45 minutes and present it back to the users after I've clobbered roots, made a mess of the roots and stuff, so they'd have to rediscover and re-image everything. But I want the discovery process and the CMH push-rack to have all the custom changes in it already, so you don't have to do anything manually later. So if there aren't any other questions, I am done with lecture for the day. It is possible if everybody gets stuck on the same thing at the same time that we can go back live to WebEx and do some demos or poking around. Hopefully it didn't get too frustrating for you yesterday, but I'm sitting there trying to respond to your email as quick as possible. Any questions? If not, I'm going to leave it to email and lab. So you should be able to see a whiteboard now. Again, I would not spend time on the inventory stuff. I'm not sure if Kevin got through Discover, but you're going to be rediscovering today anyway, so you can just start off in the IB lab. Well, actually, you need to have Discovered to do IB. So Kevin, if you haven't discovered, finish that. Send me an email if you get stuck. But today's lab assignment is to do the IB lab, the Appendix 20, page 28 to 31, and then the customizing lab from 32 to 41, and you can stop when you get to NIS. If you're not worn out, go ahead and struggle with NIS, but that's where I intend to pick up tomorrow morning. Most people basically get images built by the end of the day, but they have not necessarily dropped in the post-install and per host scripts and discovered yet. So let me see here. And again, most of tomorrow will be just getting this thing ready. And I'm going to cover the user module tomorrow, just one module. So let's see here. So most people get to A41 by the end of the Tuesday. If not, at least be at A38. Just before ETH config. Images are built. And again, you know, while these images are building, you can take care of email and do other things or poke around, go back through the workbook, things like that. Is this clear enough?
Yes.
So, again, break time for anybody. It's my lunch. I'll be back online in about half an hour to take care of any questions. Don't be afraid to email me even late at night. It's all on your pace and your schedule in your window of opportunity. So let me know, Kevin, if you have any problems.
Okay. Yeah, I think I got everything discovered last night, so I think I'm okay.
Okay, good. And again, repetition is good. At some point, you can like to reset the database and rebuild the cluster. Again, the point is, once these custom changes are made, I can reset the database, go back and discover, and have a golden root with custom changes in it. And the only thing that you're going to tweak by hand is NIS. Again, that's because of pushing maps around and the timing problems that are occurring during discovery. The master NIS is not configured yet when you're trying to configure the slave. So if there aren't any other questions, I'll be online in half an hour, and we were going to start an hour later tomorrow. And tomorrow morning then I'll review any problems, questions, issues, poke into NIS, take a break, and then cover the user module. I'm hoping by the end of tomorrow we are running one application called MPI Pong, and there's another application called MXP, Mandelbrot Generator, but I'm not expecting you to get that running yet. But the Mandelbrot Generator will require X11 and all the RPMs that are listed to be loaded. And I will be checking on your systems to make sure you've got proper things loaded and stuff. So I'm hoping by the end of tomorrow you're ready to pass your cluster off to me to test as an end user to see if it's bulletproof. So if there aren't any other questions, daw@sgi.com. And we'll see you tomorrow morning. Again, 10 o'clock Central Time, 11 Eastern, 8 o'clock Pacific. Seems right to me. Talk to you later then.
Okay. Thanks, Dave.